Good morning, friends. The purpose of this presentation is to talk about how we can have a great outcome after cataract surgery for Lasik patients, for myopic Lasik patients, and there has been a lot of debate on which IOL calculation formulas we can use to get a great outcome for Lasik patients. But to me, the question is not just starts and ends with IOL calculation formulas. Even before that, we may have to take a step back and to think of how we generate the keratometry values for these patients. Is there a best way to generate the keratometry values for this myopic classic patients? So in short, even before thinking of which IOL calculation formula to be used for this Lasik patients, to me, the most important question is how do we generate the keratometry values for these patients, and is that the right way, or is there a better way of doing what we are doing today? Now to answer this, we need to understand how the keratometers and the topographers work and how do they generate the keratometry values. The manual keratometers measure a ring which is around 3 millimeters of the cornea. The autokeratometers would measure around 2.5, 2.6 millimeters of that ring. Well, the IOL master measures around 2.5 millimeters of the ring. The lens star measures around two zones, two rings, 1.65 millimeters, and the other being the 2.3 millimeters roughly. Notice here everywhere I'm talking about a ring. I didn't talk about a zone. Measuring a ring means you are generating your K readings only from that ring and not from the zone that is within the ring. So all these keratometers, whether it is a manual keratometer or an auto keratometer or the optical biometry based systems or the variant from Alcon, they all measure a ring which is of different diameters, of different makes, but they all measure a ring. So the challenge over here is that, remember, for the LASIK patients and especially for the myopic LASIK patients, the flattest portion of the cornea is not in the 3 millimeters ring or on the 2.5 millimeter ring, but the flattest portion is within the central 1 millimeters or central 1.5 millimeters of the cornea. That's where your flattest portion for this myopic LASIK patients' corneas are. And if we are not generating our K readings by measuring this area, then we can meet a surprise, right? So if we measure a ring which is at 3 millimeters or 2.6 millimeters, it clearly misses the flatter portion of the cornea for this myopic LASIK patients. Now the question is the topographer any better? Well, sure it is, because it is based on the Placido disc technology. It measures a zone, right? Unlike the keratometers, it does not measure a ring, but a zone, right? So it stands a better chance of understanding the flat cornea of the post-myopic classic patients. But here again, there's also a challenge with the Placido-based topographers because of the camera being in the central 1 millimeter portion of the Placido disc. Now, because of the camera, it will not be able to measure the central 1 millimeter of the cornea, And the data that is given in terms of the Placido disk is basically an extrapolation from the central 1 millimeter. It does not directly measure it, but it gives you an average value. Uh, and therefore, since we know that in myopic Lasik patients, the flattest portion is in the central 1 millimeter to 1.5 millimeter of the cornea, though the topographers measure a zone, yet it may not be able to give you the perfect readings of the K readings because they miss out the flattest portion of the central 1 millimeter of the cornea. So the challenge is, if we are not able to measure the flattest portion, the central 1 millimeter of the cornea, then we run the risk of a hyperopic surprise, because if we are not measuring, especially for example, if we are measuring it through the keratometers, it measures a ring and it may give you a value which is steeper than the central 1 millimeter of the cornea. And if it gives us a steeper corneal result, then we will be selecting an IOL power uh, which would be less to counter the steepness, and therefore we may result in an hyperopic surprise for these patients. So what is the how do we overcome this? The answer could be in the Shameflug based topographers, or in one word we call it as tomography. We know that in this tomography we have a rotating camera. For example, the Pentacam, the Galilee, they have a rotating camera, and when you have a rotating camera, you stand a better chance of measuring the central 1 millimeter of the cornea, again the flattest portion of the cornea, after a myopic Lasik treatment. But however, there's a challenge again with these machines, with the tomographers. Uh, though they are based on the rotating principles, yet they generate a lot of maps. They generate the axial map or the sagittal maps. They also generate the tangential maps. They generate the simulated keratometry maps. They give us a simulated keratometry. Uh, they also have a variety of maps like true corneal power map, refractive power map, true corneal net power map. So which of these maps should we take into account for the myopic Lasik patients? Now, apart from the complexity that is created with a lot of topography maps that we get in Shameflug based tomographers, there's also another difference, and the difference is in the form of corneal index, refractive index. Well, we know that the keratometers do not measure the posterior cornea. They historically measure the anterior corneas, and therefore they take a much simplified corneal index of 1.3375. When it comes to tomography, Shameflug-based tomographers, they take a different corneal index, which is more of a true indices of the cornea, which is 1.376. They also take into account the ear, that is the interface between the ear and the anterior cornea, and also they take into account the um, aqueous humor refractive index. So this actually gives us a true understanding of the corneal refractive power maps, which is quite different from what we get from the keratometers. Now this is okay. I mean, when the keratometers take 1.3375, which is not the true indices of cornea, it works okay with uh, the normal patients. But when it comes to post-myopic Lasik patients, taking a simplified 1.3375 corneal index may not work very well. That being said, then, which of those tomography maps actually we should concentrate on? What do they mean? What do they mean? And which of those maps actually we should be considering for post-myopic Lasik patients to take the K readings? So to answer that, let's look into the different power maps and what do they mean. We have the sagittal curvature map, and the sagittal curvature map, no information on the posterior cornea is got. So these are the power maps which we cannot look into because in a post-myopic classic patient we know that the anterior and posterior corneal ratio is changed. So any map that only takes into account the anterior cornea and presumes that the anterior and the posterior corneal ratio will be the same. Uh, these maps do not work very well for post-myopic classic patients. They might work well for normal patients, but not for the post-myopic classic patients. The refractive map, the refractive power map is based on 1.3375 of the refractive index, and which we know that is a simplified corneal index values, which is not the true corneal index. And the other, however, they are only measurements from the anterior cornea. They do not take into account the posterior cornea, much like the sagittal curvature map. The difference between the sagittal curvature map and the refractive power map is that as you move from the center to the periphery of these power maps, you will see that the power increases because of the spherical aberration. So this refractive power maps take into account the spherical aberration that happens and based on the Snell's law. So the refractive power maps are anterior power maps based on the simplified corneal index of 1.3375, but they also take into account the spherical aberration. But as we said, we are discussing post-myopic classic patients. So since these maps do not take into account the posterior cornea, these maps cannot be trusted upon for the post-myopic classic patients' K readings. The third is the total corneal refractive power map. And as the name suggests, the total cornea means it takes into account the anterior cornea, it takes into account the posterior cornea, and it takes into account the true indices of the cornea, which is not the simplified 1.3375. I repeat, which is not the refractive index of the 1.3375 which the keratometers take. So the total corneal refractive power map, I repeat, takes into account the anterior cornea as well as the posterior cornea, and they take into account the true indices of the cornea, that is the 1.376, that is the anterior and the posterior corneal index. They also take into account the air interface and the aqueous interface and the corneal indices and the indices of refractive indexes of those mediums, the air and the aqueous humor. But can we take these readings and put it into our IOL calculation formulas for post-myopic classic patients? The answer is no, because the post-myopic classic patients, the corneal index is 1.3375. These formulas base their calculations on an index of 1.3375. So if we are taking these values and putting it into the post-myopic classic calculation formulas, then there will be a mismatch on one, because the total corneal refractive power map takes into account true indices of the cornea, which is different than the 1.3375 that is taken by the most myopic IOL calculation formulas. So we cannot take this values into the calculation formulas. So again, the question remains is that which power map then can we rely upon for the post-myopic classic patients? And the answer is the Holiday EKR map, to the best of my knowledge. And I will explain what is the Holiday EKR map in the next slide. My answer is the Holiday equivalent K reading. This is a map that is available in the Pentacam, and this was developed with Dr. Jack Holliday's inputs, and this to me actually is the one which actually you can take and put it in a post-myopic classic patients. So to talk about the EKR, First, the first step, there are two steps in EQL. The first step is that it takes into account the true indices of the cornea. Second, it takes into account both the anterior surface and the posterior surface. Now that it has got the right power of the cornea, it then calculates back what would be the anterior corneal values based on the historical corneal index, which all the IOL calculation formulas are using, that is 1.3375. I repeat, there are two steps. The first step is that it first evaluates the anterior cornea, understands the posterior corneal values based on the true corneal indices, like the refractive power, like the total corneal refractive power map that we discussed before. Once it has got the corneal power map of both anterior and posterior with the true corneal indices, it then converts it back into anterior corneal values with the historical corneal index of 1.3375. Once you have got this, you can now input it in not in any post-myopic Lasik patients. Remember, you cannot put these values in the post-myopic Lasik patients. You can now input this corneal reading into any IOL calculation formula, which is meant for a normal patient, because you have now back calculated this into anterior corneal surface values based on your historical corneal index, which most formulas take, which all the formulas take, 1.3375. So it is like, what is your anterior corneal value now based on the historical corneal index? But you have already accounted for the anterior and corneal ratio with the true corneal index in the first step, and then back calculated it to the anterior corneal values with the historical corneal index, which is 1.3375. Now, this is the output page of the EKR, the equivalent K readings. It is also called the EKR 65 map. And you can see, as we were discussing, the central 1 millimeter is the most important because you have the flattest portion in the myopic Lasik patients. So you get the readings in 1 millimeters, in 2 millimeters, in 3 millimeters, in 4 millimeters, and so on and so forth. But the 4.5 millimeters is highlighted because that's basically the 65%, the EKR 65. So that's basically the average. And you have also on the left down part, you also have the picture over there which shows the spread of the corneal astigmatism, the corneal values. And the more spreaded it would be, the blue, the region, the more it would be spreaded, the more it would mean that you have a lot of difference between these zones, the 1 to 2 to 3 to 4 millimeter to 6 millimeters. You have a lot of difference, and that could be an indication of some amount of irregularity also. And you also have to the right at the bottom part, you also have a visual depiction of that power map, which also gives you an idea about the regularity and irregularity. And in the middle, you can see the KS65 results. That's taken from the central 4.5 millimeter zones. So K1 and K2 values, and you also get the pupil X and Y coordinates. To me, this is also important, and it gives you the pupil diameters also. So the X and Y coordinates actually helps you in the centration, understanding more about the chord length and the angle of the visual axis and the pupil axis. So this to me is very important. So my suggestion would be to the EKR map, and the equivalent K reading map was developed in association with Dr. Jack Holliday and is found in the Pentacam, and this map can be banked upon for the post-myopic Lasik patients. Question is why? To answer this, we have to understand two things. One, this map was designed to understand both the anterior and the posterior corneal values with the true indices of the cornea. It also takes into account the refractive effect of the cornea, that is the Snell's law, that is the spherical aberration. And as you go from the center to the periphery, the power of the cornea increases because of the spherical aberration. So it takes into account both anterior and posterior cornea, takes into account the Snell's law, spherical aberration, and is based on the true indices of the cornea. That's the first step. The second step is, once these values are got, it converts it back into anterior corneal values with the historical indices that most keratometers and IOL calculation formulas take, that is 1.3375. So the first step was to get the net power of the cornea, the anterior and the posterior, with the true indices of cornea and the Snell's law of spherical reflection aberration. And then once that has been got, it then converts it back into anterior corneal values with the historical indices that the IOL calculation formulas employ. So because the EKR power map considers the radius of curvature both anterior and posterior surface, while at the same time matching the output one would obtain from an untreated cornea, assuming a refractive index of historical refractive index of 1.3375, its output can be used in IOL formulas, not in myopic Lasik formulas, but in a normal IOL formula, because this output has been matched in such a way that it reflects an untreated cornea. It is calculated with the help of the refractive index of 1.3375 to give you the final output of the anterior cornea for an untreated eye. And this can be now put into any IOL calculation formula that you have been using, not the post-myopic Lasik formulas, but the IOL formula that is of your choice that you're using now. So to me, the EKR power map is simplified and it can be used for the post-myopic Lasik patients, but you have to use these values in normal IOL calculation formulas for the reason that I explained. Of the holiday gear, you can see the blue line in the left bottom part is spread out. That means that it has a huge, almost 10 to 12 diopters of variation in keratometry powers over the 4.5 millimeters zone. That actually indicates some amount of irregularity, and you can also see on the right part, the cornea looks a little irregular. So just to explain the eCare power map here, what you see on the top is the power maps, the readings related to the 1 millimeters, 2 millimeters, 3 millimeters, uh, 4 millimeters, 4.5, and so on and so forth up to 7 millimeters. For myopic Lasik patients' IOL calculations, do you need a 7 millimeter value or a 6 millimeter value? Probably not. You'd want to take the measurement values like the keratometer from the visual axis. So you might go with a 3 millimeter or a 4 millimeter or a 4.5 millimeter. So that's up to you. But one of the, remember we started this discussion by saying that the flattest portion of this corneas in myopic Lasik patients is in the middle, in the central 1 millimeters to 1.5 millimeters. And that is what you can see. You can get the readings right from 1 millimeters to 2, 3, so on and so forth. And on the bottom left, you can see the spread of the corneal values. You can see as you move from 1 millimeters to 4.5, 5 millimeters to the periphery of the cornea, you can see that the power fluctuates. So that's an indication of an irregular cornea. And you can see on the right, bottom right picture, a little irregularity is there, quite a little irregularity is there. And in the middle, on the bottom part, in the middle, you get the K1 and K2 values from the 4.5 millimeters. That's the average values. You also get the pupil X and Y coordinates, which I would regard this as the angle kappa. And so this is how actually we read the holiday e-care map. You can take these values and put it into the any IOL calculation formulas, and which was explained in the last slide. So friends, to summarize, post-myopic classic patients, depending on the keratometers, can be risky because they only take a ring, and that ring does not measure the flattest portion of the cornea, which could be well within the ring in the central 1 millimeter, 1.5 millimeter of the cornea. If you are taking your readings from the Shameflug based topographers, then there are a number of maps. Which map you are going to bank upon? That was the purpose of this presentation. And as I talked about, you could well go ahead with the holiday care map, which is there in one of those Shameflug based topographers. That's the Pentacam. I hope you enjoyed going through this presentation. Thank you very much for your listening, for the listening.